Okay, so I want to start off tonight with this is going to be one of the most difficult, I think, units because the graphs get pretty confusing. So you have to make sure you study the axes, you study the labels on every line. You have to know these graphs. A lot of it is similar stuff over and over again, but you got to make sure you know what's going on. So I want to begin with the three different graphs I'm going to talk about, the three imperfect comp graphs. And then after that, we will talk about, it's really dark. We'll talk about the most common errors that you see. So graph number one is a monopoly. A monopoly. A monopoly is a market that's dominated by a single seller. That single seller is a price maker. They control the price for the industry. They don't have any competition. Okay. So it's a single seller in a market with high barriers and control over their price and no price competition. That is a monopoly. Now, the reasons that they can be a monopoly, some of the things that protect them or those barriers include economies of scale, control over resources, and patents and copyrights, things that prevent other people from. I'm sorry, guys. I have to take out my contact lenses later. My eyes are burning. Okay. Anything that prevents people from competing. Okay. So the graph that you have to know, I'm going to draw it out step by step for you. The first thing is your axes. Next, we have to add our demand curve. Now remember, in perfect comp, yesterday I told you Mr. Darp. He is perfect, perfectly elastic, a straight line. But in a monopoly, that is not the case. Monopolies face downward sloping demand curves. So here is my downward sloping demand curve. Now, in a monopoly, it's different than a perfectly competitive market because perfect competition, D equals MR, or MR equals D, Mr. Darp. But in a monopoly, that is not the case. In a monopoly, MR does not equal D because every time they have to sell an additional unit, they have to lower the price. And that means they lose the revenue not just from that unit, but all the previous units that they had to then lower their prices on. So MR falls much more rapidly than demand does. So our MR curve looks like this. Now what you see is MR goes negative, and that is very important, okay? So you have MRD equals AR. MR equals D equals AR. Okay, MR does not equal D, but D does equal AR. So now what we're missing on this graph is our P. Where's our price? And that's where it's tricky. In a monopoly, Mr. DAR does not equal P. Okay, that is not how we set it up. We want to produce, if this is a profit maximizing monopoly, we're going to produce at the profit maximization rule, MR equals MC, tattooed across your forehead. Right? You see this every time you look in the mirror. Okay, so MR equals MC is located right there at that intersection point. Okay, so I'm going to go to MR equals MC. I'm going to drop it down, and I'm going to label it quantity for my monopoly, QM. Quantity for my monopoly. Now, if I were a monopoly and I controlled my price, I'd want to charge the highest price. So I would take my quantity all the way up to my demand curve to see what people are willing and able to pay. Okay, and this is going to set my price for my monopoly right there. Most common error on this graph is setting the price. Okay, most of you remember quantity is MR equals MC, but how much do you charge? P equals D. Okay, so MR equals MC, up to P, up to D to find your P. All right, there it is. So there is the graph for the monopoly. That's the basis. Okay, that's the basis. What I'm not showing you right here, though, is if this monopoly is at a loss versus if this monopoly is at a profit. So I want to show you if this monopoly were at a profit. Well, I would need to include my total cost curve, okay, my ATC curve. So I'm going to go ahead and draw that now. All right. To find my profit box, I have to measure the difference between my price, it's right here, and my cost at QM, which is right here. So if I draw a rectangle, price over to quantity, quantity down to cost, cost over to the axes. I have a rectangle now. That rectangle represents my profit. I'm going to color it in so we know that's my profit. Where's my consumer surplus? Well, where it always is, price to the demand curve and up. Price to demand and up. And then finally, you guys all know what this triangle over here is called? You see it, this little triangle right there? That is our dead weight loss. It's our dead weight loss. Dead weight loss is the loss to societal welfare because we're not operating. Yes, yes. We're not operating at our socially optimal level, so we have dead weight loss. Socially optimal would be where D equals MC. So if price were right there at D equals MC, we would have no dead weight loss and we would be socially optimal, okay? So if the test asked you to identify the socially optimal quantity, you would want to identify it at that point right there, okay? This would be quantity socially optimal. I labeled it QSO. Okay. Another thing they try and trick you and ask is, what is your quantity at revenue maximization? Revenue is maximized, total revenue is maximized when MR equals 0. So I'm going to drop this low so you can kind of see what I'm doing. All right. I labeled that one quantity at revenue maximization. So those are the 3 different quantities to realize on a monopoly graph. Let me check my list for my most common stuff so I know I'm covering what we're supposed to. All right, price, MAR, shading profit, got that. All right. Monopoly and how it's different from perfect competition, I said that. So I said all 3 of these things. Let me check those off. All right. A natural monopoly. Okay. Natural monopolies we did touch on in class, but it was very fast. So I want to make sure I get back to it. Where's my natural monopoly graph? Because a natural monopoly is one where our cost will decrease. Our cost will decrease for the indeterminate future because as we grow, we experience more and more economies of scale. So here is a graph. This one's a little confusing, but a graph of a natural monopoly. So I want you to see that on this graph. Oh, I gotta get close. Okay, so here we have our price axes and our quantity and our price, demand, and MR. Now, one of the things that I want you to realize though, MC only is the small part of the Nike swoosh. It doesn't slope back up. That means it's a natural monopoly. And this one is showing you that in the long run, originally we had this LRATC, and then we dropped down to this one. And our MC went from here and dropped down because in a natural monopoly, we will slowly decrease our costs as we experience economies of scale. So if you have a marginal cost curve that's not the complete Nike swoosh, that's only a small part of the swoosh, it's probably a natural monopoly. And that's what they're trying to ask you about. All right. Remember, socially optimal is where demand equals MC equals P. Okay, when price is equal to the demand curve equals to the marginal cost curve. That is socially optimal every time. Okay. All right. The other thing they ask about is fair return pricing and what it means for something to have fair return. And fair return simply means that there's no profit, no super normal profit for the company. They are only going to experience normal profits or break even. So they're going to produce where the price is equal to the minimum point of their ATC curve, because that's where they're going to make all the money to cover all their costs. So they will be good. That is considered fair return. Okay. So that was natural monopolies. I'm checking off my list to make sure I talked about that and that. Okay. Now, price discrimination. The difference between a monopoly that price discriminates and one that does not is one that does not looks like that graph I drew earlier. Okay. This is non-price discriminating. And you know that because here we have a consumer surplus. If this were a price discriminating monopoly, they would charge every single person their maximum price, meaning that there is no MR curve. MR would be equal to D. So this MR would slide out here and be equal to D. There'd be no consumer surplus. Everything would be producer surplus. Everything would be producer surplus because each person is charged a different amount, their maximum amount. So all that money goes to the producer. Okay. So that means when a monopoly price discriminates, they are maximizing their surplus. Okay, that is everything for this page. Let me look at the next page. A monopoly with profit, I did that. Okay, so if you have questions about a monopoly, let me know and I will try and answer them. But I'm going to move on to monopolistic competition. Okay, the difference between a monopoly and monopolistic competition on the graph is not that much. You could draw something like this, okay? But what you have to remember, in a monopolistically competitive market, this company is making a profit. If it's a monopoly, in the long run, they don't have to worry about it. No competition means they keep all the profits for themselves, okay? But in monopolistic competition, it graphs like a monopoly, but acts like competition. Perfect comp. So that means if they're making a profit, everyone else is going to jump in this market to start producing and selling and getting that money, okay? So if everyone else is trying to get that money, then this is going to change. What will happen is as more and more people enter the market, their demand is going to fall. So their demand and their marginal revenue have to decrease, okay? And when D and MR shift to the left, they decrease. So will that MR equals MC point. So this quantity is going to change. Instead of being here, it's going to fall down here, okay? And what's going to happen is it will fall and fall until the quantity is equal to the MR equals MC. And when you go up to your price is equal to D equal to ATC. And I have a graph to show you that. Okay. So this graph, I'm going to show you my best. I'm going to do my best to see. Okay. So on this graph, you can see that it was drawn so that we have D and MR and MC. MR equals MC up to here to set the price, but that's also where we hit ATC. Okay. So that means that we are at long run equilibrium because MR equals MC. Okay. And D equals P equals ATC. Okay. So that's a long run equilibrium in a monopolistically competitive graph. Now you're not going to get this in a regular monopoly because there's no competition. They can just keep their prices high and no worry about it. No worries. Oh, I'm so tired. Okay. But in monopolistic competition, they can't do that. Okay. Now, the final graph I want to make sure I show you, because we haven't looked at it in a long time, is a oligopoly graph. I don't think you will see this on an FRQ. I think you would only see this on a multiple choice question, but I still want you to know what they look like and why they look this way. Okay, so the graph I'm going to draw for you is, I told you guys to remember that they are kinky. We have kinky graphs for oligopolies. All right, so here we go. Start with your axes, P and Q. Now, what is special about an oligopoly is that it is a market that's dominated by 4 or fewer firms. That means 4 or fewer industries control the majority of the market share, 70% or more of the market share, so that they basically have price power, price setting power. Now, oligopolies are interdependent. What one does will dictate another's behavior and actions because they are so interconnected. Now, that can be a good thing, okay, but it also can be a bad thing. If they try to collude or form a cartel, they're going to basically operate with monopoly power, and that is not something that we want to see happen. But because they're interdependent, it does push them to innovate, because as one comes up with new ideas and new technology and new things, the other ones are going to be pushed to keep up. So we do have that as a huge perk. All right, so now let's go back to my oligopoly graph. Oligopolies are special because they actually have 2 different demand curves connected together. The first is an elastic demand curve that hits an inelastic demand curve. So we have ED, ID. So I'm going to draw that. Okay. So here's our first little bit of an elastic demand curve. And then it turns into an inelastic demand curve. Okay. So it's kind of strange. Now, since we have 2 different demand curves, we also have 2 different marginal revenue curves. So here's our first MR curve. Okay. All right, so the MR curve looks something like this. We have this first top piece that follows the elastic demand, and then we drop, and that's called the kink, because all of a sudden it disappears, and it picks up later down here with the elastic portion. I'm sorry, the inelastic portion of the demand curve. Elastic, inelastic. Now, the trick about an oligopoly is that it does not matter where its marginal cost curve falls along that kink, as long as it's on the kink, right? If they have this MC curve or this MC curve, their quantity is still the same and their price is still the same. It doesn't change their behavior. But they want to produce at that point on the kink, because that is where they're going to maximize their profits. If they produce on the kink, their price is at that peak of the inelastic demand curve, but it's at the bottom of the elastic demand curve, elastic portion. If they raise their price up into the more elastic zone, their revenue will go down. Because remember, when you're elastic, prices go up, revenue goes down. They stretch, okay? So that is an oligopoly graph. They're kinky. And why? All right? So there's that. I think that was all my graphs to make sure we covered tonight. I'm trying to think. The only other thing I want to make sure we remember is game theory. You may or may not see a question on game theory, but I want you to remember that how to read the payoff matrix. Remember, not everything is a prisoner's dilemma, but we did study prisoner's dilemmas, okay? Okay, so you have player A and player B, and you have options 1 and 2 or 1 and 2. So here we have B1, B2. All right. So when we go through here, we can see the different combinations. Remember, the person on this side is always the first one, and the person at the top is always the second one. Okay. All right. So that's my payoff matrix. I'm going to see who's texting me. All right. Okay. So I think that is everything I wanted to say tonight. Unless you have specific questions, I think I covered every graph I wanted to show you. I think I'm good. All right. Okay. So then I am going to wrap it up and go to bed and answer questions tomorrow if you have them. Okay. Keep studying. Please practice drawing your graphs. Please practice drawing them yourself. Label everything. Double check you labeled it correctly. And have a good night.